welcome to STL, the 3D Printing Digital Fabrication Podcast. My name is Scott Rocca.
I'm baslisks. And I'm Ryan.
Today we're going to be talking about a couple different topics. The first one that we have is going to be Prusa, basically. Not just the Prusa anything, but Prusa himself. That's what we're going to be talking about.
Josef Prusa.
A lot of the crazy stuff that he has done, some of the really, really cool stuff that he's brought to 3D printing as a whole. And the list is fairly long. And the guy is actually still pretty young, isn't he?
Yeah, I don't imagine he's...
Like, he's in his mid-low 20s, somewhere in there?
Yeah, I'd say that.
Yeah.
I mean, we have the internet.
We have the power.
Yeah.
But some of the things that we're going to kind of go for are the Prusa nozzle, the i3, which is his newest printer that he's come up with. And it's really cool, simplified design. There's a couple other little things that we're going to toss in there, but I think we should probably start with his newest thing, which I guess would be the i3, or would it be the nozzle?
The nozzle more.
The nozzle? Yeah, okay. So the newest thing that he has out is the stainless steel nozzle, and it's a really cool little piece of work. It's a full stainless steel hot end. It's one piece that mounts into a piece of aluminum, which is the heater block for it. And it's really cool. We have one here at the Hackerspace, and we've played with it a little bit. The printer itself isn't working, but it's a Mendel variant, and there's all kinds of other stuff to get to fix with it first. But it's a really nice nozzle. The nice thing about it is it's 303 stainless, which means it's completely and utterly food safe. So that means if your filament is, if the dye isn't toxic in it, and you can check the MSDS forms on it and make sure that everything's kosher, then you can actually use it for food and stuff. You still have the microbacteria issue, but that's another topic entirely. But like, what are you some of the what was kind of your thoughts on that? Because I know you used it a little bit.
It heats up wonderfully. It stays at temp. It is so much nicer. It's so much shorter than my other nozzle tube. It's about 3/4 the size of the other one. So I get a little bit more Z space out of it. Well, yeah, I get a little bit more Z space out of it. I'm just really trying to redesign my current extruder to work with it. It's been a little slow. More my fault than anything, though. But it's a solid piece of metal.
Yeah.
Oh, it's insulatorless, which is awesome.
Yeah.
You jam it, you pull it out, and you just blow torch it, and it's clear. Nice, easy, clean.
Yeah. So one of the things that I did with that is I went online and I looked up his plans for it, and I went, I'm going to make this monstrously, garishly huge. And the reason for that is because I have my giant printer, and I needed a much larger nozzle. So I went forth and I learned how to machine, and came up with this thing that is almost twice the size of the Prusa nozzle. So I believe his is like 26 centimeters? Or no, that's huge. No. Like 26 millimeters or so, I believe is what his is. Don't quote me on that.
Yeah.
Mine is 90. Yeah. So it's quite a bit bigger. The fins on it are actually about 1.5 mils, both the fins and the spacing on the fins for the cooling on it. So what I did was I actually had to make my own little bit, and I went to the metal lathe and milled everything out. So at some point, actually, if you'd like, you can check out my blog. It's going to be down at the bottom there. And if you look down on the page, you'll actually see the nozzle that I actually produced. It was a crazy little thing. It actually does work. I tested a little bit. I don't have any photos of it being tested. I also had to make my own heater block for it. And his is about a 1/2 inch. Mine's about 1.5 inches. Which is ridiculous, but the reason for that is I'm going to use a much, much larger volume of material. And it's kind of nutty.
Well, otherwise you won't be able to get any prints done in any reasonable amount of time.
I mean, I've got a huge build volume that is measured in feet, not millimeters.
Mm-hmm.
So, yeah, it's that alone is kind of great.
Right.
But it was really cool to actually be able to reverse engineer it. And when I actually showed it to Josef Prusa, because I got a chance to meet him at Maker Faire, he just looked at it and went, "You're crazy. I was like, aw, thank you. That's so nice of you to say. And he just bewildered kind of walked away. And I was very happy.
Yeah. No, he's known for being a little crazy himself.
Yeah. But it was very endearing, and he offered me some words of encouragement, and it was really cool to meet the guy. And to just kind of go, hey, you inspired me to make this, and this is your little nozzle on steroids, and maybe horse steroids.
Or did you have the nozzle on you?
Oh yeah, I took it out of the case, I showed it to him, I was like, this is yours, just giant, and he went, what did you do? Oh God. And
well, I mean, imagine it, in a world of everybody trying to print, smaller and smaller to get, more accurate layers, you decided to go completely opposite.
Yeah, I just went, I'm going to go butt effingly huge. And just be like, yeah! Giant prints. Yeah. As a reference, I'm looking at doing 1-to-1 busts, so it should be interesting. Anyway, so...
You should do full-size action figures. It's fun.
Yeah.
That'd be really kind of neat.
Yeah. That'd be kind of scary, too.
Wait.
Like, can you scare my girlfriend?
Yeah.
And, yeah.
We're going to real doll territory.
Yeah, that's no... That's...
How about full-size rock and sock robot stuff?
Actually, they did that at this year's Bigger Bear.
Really?
Microsoft did that, and what they were doing was they had the Kinect set up, and then you could actually punch at the shapes on the screen.
What was that movie with Hugh Jackman?
Yeah.
I actually watched it the other day.
Yeah, it wasn't too bad. But you could actually punch these little circles using the Kinect, and you could have one robot punch, and then the other guy used a controller.
They also did something like that on Prototype This.
Yeah. But it was made out of all 80/20 aluminum, and
sweet.
they had big pads on the front, so if you hit them right in the chest or you hit them on the jaw, heads would pop up.
I gotcha.
It was actually cool to kind of watch people just mess around and just like,
Yeah.
It was a neat booth that Microsoft set up there.
Wow, you don't hear that very often.
They're not bad.
Microsoft's getting better.
Good.
The anime Internet Explorer commercial is...
that thing.
It's disturbing.
Yeah.
I don't think I want to know.
No, you don't.
Okay.
It's like Internet Chan or something. I don't even know.
It's like if 4chan had a baby that was half smart. Yeah, the puzzled look that you just had is what I had the entire video.
I didn't even watch the video. I just saw people doing and stuff.
Yeah, it was.
This is a bad idea.
It's beautifully animated, but the content is just like
Is it worth?
it's Sailor Moonish.
Oh, nice.
Like, yeah,
Drag that back out of the 90s.
yeah. So
What? 80s?
I don't know.
yeah. Anyway, so moving on. The other thing we're going to talk about is the Prusa i3, and the i3 is a great little printer. I've actually seen a number of them popping up. And it's a really cool little machine because it's very simple. It uses linear bearings and belts and things like that. It's a lot of the standard stuff that printers use, but it's an open framework. And everything is millable, cuttable, printable, very easy to put together machine.
Parametric too.
Yeah, parametric. So, what don't you talk about? I think you have a little bit more experience with them, just because I know you know a little bit more about them.
I've been wanting to build one. Take my current Prusa Mendel and turn it into the i3. So the real reason why I just got into the Prusa i3 is because I could do the Prusa Mendel. And it was simplifying the parts to what you need as the basic setup and then just going with it. The i3 does that even further. It gets rid of a lot of the printed parts because it's awesome that it can replicate itself by printing. But that's a lot of work. I made another, with my cupcake, I made a original Mendel, and that's like, I can't even tell you how many hours that was of printing. We were just here every night printing and printing and printing. Yeah. And then the assembly of that made me realize how awesome the original Prusa Mendel is. But looking at the i3, it's just...
And the guy that you actually did all the printing for, he brought his in, right?
Oh yeah, it works.
Yeah, it works, and it works well.
No.
He's been tuning it in. Last time I saw it, it was actually doing some pretty good stuff.
He said it can only do small parts, but that's more because he just doesn't work with it much. I mean, he's been busy.
Yeah. Aren't we all?
But yeah, the Prusa Mendel is a simplification of the Mendel, and the Prusa i3 is a simplification of the Prusa Mendel. It really is. It's taking care of all those parts is just wonderful, and I like rep, but I like this direction too. I don't want to compare it to like a cupcake, but it is kind of like a cupcake. It's a printer. It works now, and that's all you really care about.
Well, can you do like a better comparison though? Like, how is it more like a cupcake in that it's a cupcake in that it's in the base of the design and it's moving forward, or and for folks that don't know what a cupcake was the first iteration of the MakerBots that came out. So it was the very first product very first printer that MakerBot ever put out. And there's tons of videos, and if you want, you can go look it up. It's kind of a Hall of Fame Smithsonian piece almost at this point. But why do you make that comparison?
So it's the frustration of you're printing all these parts. Printing takes a lot of time. I can cut this out of plywood in a quarter of the time and just get a printer running.
Yep.
And it'll be cheaper because you're not spending all that machine time, and then wood can be cheaper than plastic.
Yeah.
That's why I'm comparing to a cupcake. It's not a cupcake. It's pretty much the Mendel. It's the Mendel design turned into a box frame and just kind of refined some.
Okay. So yeah, I mean, it's a really cool little design. I'd love to actually, once we get our CNC machine here at the Hackerspace back up and running, I'd love to actually go through and kind of crank out a couple of them, a couple of the frames, and just have them as base kits that we could sell to help donate to Arch Reactor. Because I think that would actually be something kind of cool to do.
Well, we were talking about doing prosthetic stuff for amniotic band people.
Yeah. That's another topic entirely as well,
but that'd be the perfect printer to set them up on, just have them learn on, because it's like you can get one of those going for about the same cost as any of the cheaper printers, but you're gonna have a little bit more reliability, or not reliability, but a little bit more easy to repair, because it's like, I broke a part of my box.
Yeah.
Well, I could technically take this to a table saw, and just rip a couple of cuts, and then just bolt it in, and it'll work.
That's 10 minutes, 15 minutes of work.
Yeah. So, I mean, in that regard, it is actually a good idea to go forth and produce these these kits for it, in that you produce the hands and you produce the prosthetics for people, and then you say, okay, if you want to make changes, you want to customize it, if something breaks on there because for whatever reason you were out late one night and just, because 8-year-olds drink so heavy.
Yes.
And it's like, I just punched that speak and spell right in the speller. And now my prosthetic is now broken. It's a way for them to reproduce the parts, and it's a cheap way to do it. It gets 3D printing further out there, and it's definitely something that I would actually like to see us explore, not just as a hackerspace, but
as a 3D printer community.
As a community, in trying to get.
That's the reason why open source is good.
Yes.
Yep. This would have happened with this was not open source.
Yeah. And that's the really cool thing about doing all this open source, is that you get guys like Prusa, and you get I can't remember his name for the life of me. He was just given a big award. The guy that actually produced the first printed prosthetic for the guy down in South Africa.
We'll link the video.
So you have stuff like that happening, and right now it's still the very early stages. It's the first. And once you get past that, then it's like, okay, well, how do I do maintenance and upkeep? Am I going to have to go back to this guy who's busy as hell and try and get him to print me more parts? Or if I have this little kit, I can make my own. And as I get older, as I grow, as I need to change things, or if I'm doing tasks, like if I have a hand for bike riding and a hand for climbing and this and that, so you have an appendage. Ideally, you want something that's going to mimic a real hand, but in the end, you'd be able to produce those parts.
Oh, yeah. Because you could try out things that you think
I don't think ideally that you're going to mimic the hand. I don't think the hand is an ideal tool for everything.
No, it's not.
This is the whole transhumanism thing. Like, we can ascend our meat.
Yeah. But,
Did I distract you with that?
Yeah, you did.
That's
I had a good point. And it is that if you look at some of the stuff that was happening, because we were talking about this before the podcast, where MakerBot, when they were looking to go closed source, before they went closed source, you have this argument over, do you take something like a prosthetic, like a printer, and you make it closed source so that nobody can really get a hold of the base plans, or do you keep it open source so that you're basically crowdsourcing everything and you're allowing the community at large to go forth and then edit everything and make all kinds of variations and changes that allows you to come up with a better design? Because then you go forth and you do kind of what I did with my giant printer, and you cherry pick some of the best designs, some of the best features, and you see what you can come up with based on that.
They don't even have to be the best. They're just the aspects that interest you.
Yeah. And it can be that as well.
Yeah, that's why I always consider actually community-based development to be superior, or superior in conjunction with the base core team of people who are either paid or totally devoted to it.
And who's to say it couldn't go like halfway between that, where it is closed source and it is open source. So you have some proprietary parts that are closed source because they're very complex or they're dangerous to make.
Well, you look at current enterprise systems, like a lot of it is on Linux, a lot of it's open source apps, but then you'll have like some closed source stuff running behind it because it's like they saw a market and they jumped into it. And their result was just better, or they had better marketing too, but I'm not going to talk about that.
And then on top of that, you've got non-commercial licensing. So all of the people who do hobby stuff can actually jump in without having to hire a lawyer or a team of lawyers, or pay $15,000 for a pack of licensing.
Yeah. And at the same time, you're taking that, you have a low-cost 3D printer, and you can produce objects like those prosthetics for low cost, and you're changing the whole dynamic of the market.
Yeah, and you've got people with the community, they're actually closer to the problem anyway.
Yeah. And it'd be interesting to see, like, a lot of Hollywood people kind of chime in, because the guy who did the South African hand was actually a Hollywood puppeteer.
Oh, okay.
So the first one that was produced was designed by a puppeteer, because that's how a lot of animatronic hands actually work.
Yeah.
Is that it'll have lines that run back, and each of the fingers has a torsion spring.
Well, just like your tendons in your hand.
Yeah, exactly. But to see Hollywood chime in on doing some of the prosthetics where you can actually cover it in something that's a flesh tone, or to do something like that from the special effects kind of area, to see kind of what their input would be, because you have an industry already that's making these prosthetics that have to look and move and operate real, but then it's interfacing that with a person. It's what kind of input can they offer to help to further the designs, or help to further making these people more ambulatory. So, I mean, it'd be kind of cool to, stick a little screw gun motor on the end of the hand, just spin.
I like the Terminator arm.
Yeah. Minus the whole cutting off of skin.
Really? Do we have
the Terminator arm is a brand of... Oh, no, I'm thinking is it the Luke arm? I can't remember. Oh, who cares?
Oh, like...
an actual prosthetic that's in the world nowadays. Yeah. It actually does a rotation because they're trying to replicate the wrist movement.
Yeah. I do know that there's one guy who works in Washington. I believe he does something with defense, and he has a full prosthetic arm from about the shoulder down, and it actually communicates.
To give you guys a minute.
Okay.
We're
on the internet.
It'll actually communicate with the muscle movement, and I do know I've heard of kids who at a very young age will actually get implants done at the base of their skull, so that it'll actually measure the movements that they're trying to make, electrical impulses, and then that'll control the prosthetic. But those are $100,000.
Yeah, subcutaneous interface is incredibly expensive.
Yeah, but and then
it doesn't have to be subcutaneous.
Yeah, but then like each year, those kids have to get new prosthetics, and then the firmware and hardware and software, all that shit gets upgraded. So it's like this expense is just gigantic. But when you take it back to just being mechanical, you go Evil Dead on it, and it's like,
Rudy.
Hail to the king.
Yeah.
The king being Josef Prusa.
But, okay, so you made me think about this. You could take a Nia from, I can't remember who does it, but it's a helmet that you wear, and it can kind of read what you're trying to do.
Okay.
And you could probably strap a pie in here, and then a battery here, and then do the whole robot arm stuff.
So put your right hand in. Oh wait, never mind.
That's
Well, you can also
a lot
do
of
it-
work and a lot of money.
Well, you can also do it too with a Raspberry Pi, where it's going to measure muscle movement, and then based on the muscle movement, kind of like what they do with wheelchairs for people who are quadriplegics, and measures the breath. You can measure the muscle movement, and based on that, you can control motors and servos.
Yeah, and they actually do that nowadays with that the sound of muscles moving rather than without like having to measure the impulse.
But it'd be interesting to see doing something like that with a Pi, and then getting servos with metal gears instead of plastic gears, so you can actually get a little bit more torque out of them without breaking. But seeing something like that would actually be kind of interesting, and seeing how low cost they can still stay and still be within the normal consumer, like what's considered like the consumer range. So like the $500 to $3,000 range.
Yeah, if it's say a tenth of the price of full-size prosthetics, it'd probably be excellent.
Well, I mean, it'd be a full-size prosthetic, but you're talking like full-blown medical grade.
Tenth of the cost.
I mean, that'd be really interesting to kind of see that side of things explored now that we have a base to work on for the mechanical side.
Yeah.
And I do know Google had a commercial a while back for a guy down in Tasmania who lost his arm, and he actually found plans from the early 1900s for a full mechanical prosthetic that actually uses
Cams.
Back muscle.
Yeah, he uses back muscle. So then, like, as he would spread one arm, like the other arm would mimic it. And then he could actually still, like, he could weld with it. Like, and the video is, like, kind of heart-wrenching, and you, at the end, you're like, oh, God. Oh, Google, I love you. You kind of have that warm and fuzzy moment. And it's actually a cool video, and you could even go in and look at some of that stuff and explore the patents, because the patents have expired, but they're still on file.
Yeah.
And it'd be interesting to see some of that play into it.
This is where open source, antiquated technology, and just human effort and endeavors can come together to just spit out wonderful things that make you live and be happy.
Yes. And on that warm and fuzzy note, we would like to say goodnight on this one, and thank you for joining us here on the STL Podcast. Join us next time. We're going to talk about some other really cool stuff. And my name is Scott.
Basils?
Ryan.
Thank you. See you next time. Don't troll!